Welcome students. In today's video lecture, we will learn total local attraction. A magnetic meridian at a place is established by a magnetic needle which is influenced or uninfluenced by other attracting forces. However, what happens is sometimes the magnetic needle may be attracted and prevented from indicating the true magnetic meridian when it is in proximity to certain magnetic substances. Okay. Now, local attraction is a term that is used to denote any influence, such as mm, above, like which prevents the needle from pointing to the magnetic north in a given locality. Some of the sources of local attraction are magnetite in the ground or wire carrying electric current, steel structures, railroad rails, underground iron pipes, keys, steel board spectacles, metal buttons, access chains, steel tapes, watches, mobile phones, etc., which may be lying on the ground nearby to the instrument, that is the compass. Now, how to detect the local attraction? Local attraction at a particular place can be detected by observing the fore and the back bearing of each line and finding out its difference. If the difference between the fore bearing and back bearing is 180 degrees, it may be taken that both the stations are free from local attraction, provided there are no observational and instrumental errors. Okay, so it is assumed that there are no observational or instrumental errors that are happening or that are done. If the difference is other than 180 degrees, the forebearing should be measured again to find out whether the discrepancy is due to avoidable attraction from the articles on person, that is chains, tapes, etc. And if the difference still remains, then the local attraction exists at one or both the stations. So, strictly, the term local attraction does not include avoidable attraction due to things about the person or to other sources not connected with the place where the needle is read. Okay, so now to eliminate this local attraction, there are two methods. We will study both the methods, but again, if there is a local attraction at a station, all the bearings measured at that place will be incorrect, and the amount of error will be equal in all the bearings. This is a statement which is true in any of the method of elimination. Okay, so if there is a local attraction at one station, the bearings that will be measured at that point, all the bearings will have error, and it will be equal for in all the bearings. Now let us learn the first method to eliminate local attraction. In this, it is considered that there are no observational and other instrumental errors. This is an assumption, or this is the statement that stands true in this particular method. Okay, so we have to consider that there are no observational or any other instrumental errors. Now, in this method, the bearing of the lines are calculated on the basis of the bearing of that line which has a difference of 180 degrees in its forebearing and back bearing. So, it is, however, assumed that there are no observational and other instrumental errors, as I mentioned earlier. The amount and direction of error due to local attraction at each of the affected station is found out. This is the first step. Second, there is if there is no such line in which the two bearing differ by 180 degree, the corrections should be made from the mean value of the bearing of that line in which there is least discrepancy between the back bearing and fore bearing side. So first, how do we start with this particular method? The first step is you have to find out a point where the difference of fore bearing and back bearing is exactly equal to 180 degrees. Now if you find that there is no such line where the difference is 180, you can start with the line which has the least discrepancy between the back bearing and fore bearing reading, which has the least difference. This is what it means. Okay. So if the bearing is expressed in quadrantal system, it is taken in slightly other way. So here are some standard things that are followed if the system that is followed is quadrantal system. That is, the first and the third quadrant, the numerical value of bearings increase in clockwise direction, and in second and fourth quadrant, the numerical value increases in anti-clockwise direction. Now, positive corrections are applied to clockwise and negative corrections are applied anti-clockwise. You will understand all these things when we do a numerical. Okay. Now, the second method for elimination of local attraction is the it is considered that even if the bearing measured at a station may be incorrect due to local attraction, the included angles calculated from the bearings will be correct since the amount of error is same for all the bearings measured at the station. So, this is true in case of closed traverse. So, if you know that it is a closed traverse, we can always consider that the included angles calculated are correct. Okay. So the bearings will be changed. Bearings may have an error, but the included angles will be correct. Now, included angles between the lines are calculated at all the stations. This is the first step. Second, if the traverse is the closed one, the sum of the internal included angles must be 2n minus 4. These are the right angles. So, I mean the correct angles. So, 2n minus 4, this is the equation that is used to find out the interior included angles. Then, if there is a discrepancy in this, then observational and instrumental error also exist. Now, such errors are distributed equally to all the angles. So, again, this method will be more clear when we solve one numerical. Now, over and above this, there can be a special case in which there is no line which has the difference in its forebearing and back bearing equal to 180 degree. Okay, so there is no difference. So now in this case, select the line in which the difference in its fore and back bearing is closest to 180 degrees. So that is the least value. Then the mean value of the bearing of that line is found out by applying half the correction to both fore bearing and back bearing. So whatever the error is applied half on both the sides. So one for fore bearing and half for back bearing, thus obtaining that line differing exactly by 180 degrees. So what will happen if the error is divided exactly half on both the sides? Then the difference between these forebearing and back bearing reading will be exactly equal to 180 degree. Then you will have to proceed like method 1, that is first method, that is proceeding with the modified bearings of that line and corrected bearings of other lines are found out. So these are two methods which are used to eliminate local attraction. In the next video, we will try to take one numerical which will explain these methods in detail, and we will also get to see how this special case is taken care. Thank you.